Alrighty, so let's up the ante. Let's find the distance between two parallel lines now. Okay, not like the previous example where we were finding the distance between a point and a line. Now I'm giving you two parallel lines. Okay, the first way we're going to solve this is using a system of equations, which is going to really be what you're doing when you are solving using the graphing method. Okay, so I want to show you the system method. We have two lines here. We have f of x equals 2x minus 8. So I'm going to rewrite that as y equals 2x minus 8. And we have y equals 2x plus 7. Okay, just going to write those into slope-intercept form, not function notation. Give me a point that's on this second line, y equals 2x plus 7. Okay, well, I'm going to pick the really easy point, the y-intercept, 0, 7. Okay, the reason I'm doing that is because my next step is going to be to find the perpendicular line to y equals 2x minus 8 that goes through 0, 7. Okay, so we're going to find the perpendicular line through 0, 7 perpendicular to the equation that I didn't talk about, y equals 2x minus 8. All right, so perpendicular slope is negative 1/2. So to write this equation, we're going to do y minus the y coordinate, which is 7, equals negative 1/2 times x minus the x coordinate, which is 0. Okay, so I got y equals negative 1/2 x plus 7. After distributing the negative 1/2 and adding the 7 to both sides, that's the equation that I get. So this is perpendicular to y equals 2x minus 8. All right, I am going to find the intersection point. Find the... What's happening? Sorry, iPad's acting up. Find the intersection point. Why isn't it letting me type? What's happening? Intersection point. Sorry, it was acting up. So I'm going to find the intersection point between these two lines. So my system is y equals negative 1/2 x plus 7 and y equals 2x minus 8. All right, the way I'm going to solve this is by substitution. I'm going to take negative 1/2 x plus 7 and plug it in every time I see a y in my second equation. I'm going to substitute negative 1/2 x plus 7 in for y. It's going to equal 2x minus 8. All right, now I'm going to get my variables on one side, my numbers on the other. All right, so I'm going to have 15 equals 5/2 x. If I got my variables on one side, numbers on the other, multiply both sides by 2/5, I will get x equals 6. Okay, so the x coordinate of my point of intersection is 6. What's the y coordinate? Well, plug it back into either the top or the bottom equation. Doesn't matter. All right. When I plug it back in, I'm going to get y equals 4. So my point of intersection is 6, 4. Okay. Where the perpendicular line intersected y equals 2x minus 8, that point is 6, 4. Well, what point did we start with? We started with 0, 7. All right, so now it's going to be just like our problems from before. Find the distance between 0, 7 and 6, 4. So if I set up a right triangle, Pythagorean theorem, horizontal change from 0 to 6 is 6. Vertical change from 7 to 4 is 3. That's what I'm trying to find, the hypotenuse. So I've got 3 squared plus 6 squared is equal to d squared. So d is equal to the square root of 9 plus 36, so the square root of 45. I can break down square root of 45 into square root of 9 times square root of 5. Square root of 9 is a nice number. So d equals square root of 9, which is 3. So 3 gets to come outside. Square root of 5. 5 is stuck underneath. So my distance is 3 square root of 5. That is the system method. That is technically what we were doing up here. It's just we had a graph. All right. So what happens if we have a situation like this where we can graph? Let me show you this second way. Okay, this where we're actually going to graph these two lines. So I'm going to start at -8, go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Also go down 2 to the left 1. Okay, give myself some more points to connect. All right, so that is f of x. Now I'm going to graph g of x. So I start at 7. I go up 2 over 1 or down 2 to the left 1. Okay, now I'm going to connect those. That's g of x. All right, what point did we start at? We started at 0, 7. We picked a point on our second line, 0, 7, and we applied the perpendicular slope, which was -1/2. Down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And notice that it intersected my other line at the point 6, 4. So we started at 0, 7. We applied the perpendicular slope and it intersected at 6, 4. Okay, now we need to find the distance between those two. We need to find this distance. So I set up a right triangle for Pythagorean theorem. 0 to 6 is 6. 7 to 4 is a vertical change of 4. Once again, we have the same exact Pythagorean theorem that we did when we were solving using the system way. Okay, 9 plus 36 equals d squared. D equals square root of 45. D equals 3 square roots of 5. It's going to get the same answer. So when you're graphing, that really helps you visualize what you're doing. But what you're doing by drawing the graph is you are solving this system. So that's why I wanted to show you both methods. Okay? The system, pick your y-intercept, find your perpendicular line, solve a system to find your point of intersection. Then you find the distance between your y-intercept and your point of intersection. Or graph the two lines and do the same exact thing. Start at the y-intercept, apply the perpendicular slope until you get to the other line. That's your point of intersection. Find the distance between the 2 points. Okay? So, 2 different ways, same exact solution. Let me know if you have any questions. Make sure you do those practice problems.